So now in this video, we're going to take the LM393 comparator and use it to control a bipolar junction transistor in NPN version. The arrow's not pointing in, and it's wired as a switch right now. When we have a high signal, the transistor will be fully on. When we have a low output, when we have a low output, then the transistor will be off. And the active buzzer here, it is a buzzer. You just apply 5 volts across it. 5 volts is usually good. You can go lower too. But in any case, it will just buzz while there's a voltage across it. So a switch works nicely for it. We have the transistor switch. So the circuit is pretty simple. Let's look at the pin layout first. So we got the LM393 right there. And it's a dual comparator. One on that side, one on that side. And then the output, top left, pin number 1, inverting input, and then non-inverting input. So on the schematic, I have the inverting above the non-inverting, just like the integrated circuit here. So now I already have it wired up. This is not a complex circuit. We've been going over this before. For the voltage reference, one of these resistors, they're 100,000 ohm resistors, 1 kilo ohm, is to the positive rail, and the other one is to the negative rail. So our reference voltage is half of the power supply voltage. We're going to use 5 volts. That's going to the second pin down there. That's the inverting input. Right below that is the non-inverting input. We have a trim pot here. So that's how we're going to set the voltage, our signal voltage. So we have our reference voltage, and then this is our voltage in. And it's going to compare them. When I go above about halfway, it's going to get loud. The buzzer's going to beep right there. So that's really it. It's basic comparator stuff. So now let's look at this part of it. So the output here, I have the 10 kilo ohm pull-up resistor because all we're doing is controlling a transistor. So current's either going through the transistor when the output's high, or the current that goes through here is going to get sucked directly to ground. And that'll keep the transistor off because the base will be connected directly to ground. And so I have a white jumper from the output coming to the middle pin of the transistor right there. We're going to use the 2N3904. This buzzer doesn't need a lot of current, but it's probably still a bit high for the comparator. Looks like it's about 26 milliamps of current. So not bad for a transistor, but a lot of these integrated circuits, you don't want to go above like 20 milliamps or whatever. So in any case, flat side there, emitter left pin, base middle pin, collector right pin. We're going to turn it this way, and now the pins line up with what you see on the schematic. So emitter on the bottom, base in the middle, collector on top. So we come here, and let's zoom in a little bit. So the base, the middle pin, will go to that white jumper. Comes from the output, the emitter to the gray jumper, and collector up here. Now, the buzzer, as I said, we can just run 5 volts directly across it. We don't need a current limiting resistor or anything. It is polarized. That side's plus. We got plus there. So I'm just going to put the negative side to that orange jumper, and trying to not block your view or the light. So the negative is to the jumper. The plus, the wire up there, is going directly to the positive rail. So looks like I'm going to block your view, but not much I can do. So, in any case, there we go. That pin's to the positive. That pin's over there. That's it. The circuit is really that simple. So right now the transistor is off because the output is connected directly to ground. Thanks to this being a 10 kilo ohm resistor, there's really no current flow right now. There's a tiny bit, but quite a bit less than 1 milliamp of current for all of this. Now I'm going to raise the voltage of our trim pot, and I'm going to try to dampen the noise a little bit. I'd like to cover this more, but in any case, we'll look at the current, and there you can see it was about 23 milliamps of current right there. So I don't know if this transistor was 100% saturated. I did use a lower value before, but also that would mean there's more current elsewhere too. So in any case, it's above 20 milliamps. I believe the data sheet's not completely clear, but I don't think they want you to put more than 16 milliamps of current into the output to sync it. So again, you got to read the data sheets carefully. They're a bit tricky to read and whatnot, but I believe it's about 16 milliamps, and we exceeded that. So it may still be okay, especially because some of the power is being dissipated by the speaker, but still a better idea. Just use a transistor to begin with if you are in doubt. And so, in any case, we covered most of these topics already. We're just combining them together. We have the comparator with open collector. It just connects to ground or it's off, so we need the pull-up resistor. Covered that. Transistor switch we covered, and active buzzer. You just apply power to it. Not too hard, but that's all more complex circuits are. A bunch of simple circuits just slapped all together, working together. You just have to understand each one of them to understand the total circuit. So check out one of the other videos. Donate to Patreon if you can, and click like, the bell, and all that. I will see you on the next video.